Hi everyone, here in this video we are discussing third and fourth exercise of NCERT Mathematics textbook of class 10 chapter 1. So let's first consider question number 1. Prove that root 5 is irrational. We want to write a proof for showing that root 5 is an irrational value. For this we are contrary assuming that we are supposing that root 5 is rational. So, to the contrary, let's assume that root 5 is rational. Then, which implies root 5 should show the properties of a rational number. That means we should be able to write root 5 in p by q form. I am writing root 5 as p by q form, that's a divided by b. Now, I am reducing this its common terms or common factors of a and b, or I am dividing the HCF of a and b from its numerator and denominator. That means I am rewriting this as a divided by HCF of a and b, and b divided by HCF of a and b. Well, I am dividing this HCF of A and B from numerator and denominator. I will get the numerator and denominator as co-prime numbers. So this will be in P by Q form, or this simplest form of A by B. I will get as P by Q. Okay, let's consider P by Q as the simplest fractional form of root 5. Next step, we are squaring this term throughout. That means we are taking the square of root 5 and we are taking the square of p by q. So square root of 5 whole square is equal to p by q whole square, which implies I will get 5 is equal to p square by q square. In next step, I am rearranging this as 5q square is equal to p square. That means 5 divides p square, which means 5 divides p. So that 5 is a factor of p. Then I can write p as some 5 into k. Let k be an integer, suitable integer. So 5 is divides p, 5 is a factor of p. That means I can write 5 as 5 times k for some integer k. If so, I can rewrite the previous statements or the connection between q and p. That is 5q square is equal to p square. This statement I can rewrite using this value of p. That means here we have the value 5q square is equal to p square, and we got the value of p as 5k. I can apply this value of p into this equation, and that implies I will get 5q square is equal to 5k whole square. That means I will get 5q square is equal to 25k square. Now I can cancel 5 in LHS as well as in RHS, so that I will get q square is equal to 5k square. So q square is 5 into some integer. That means q divides 5 divides q. Q is a multiple of 5. So that I can write 5, or I can write q as q is equal to 5. Yes. Now finally I got p is equal to 5k and q is equal to 5s. K and s are suitable integer. This is a contradiction to the assumption that p and q are relatively prime, or they are co-prime number, because 5 is a common factor. 5 is common factor of p and q. This is not possible. Why this is not possible? We have already divided the highest common factor from A and B, and we have received P by Q as the simplest form. Then P and Q will not have a common factor other than 1. But we got a common factor, that is 5 here. This is a contradiction. This is because of our wrong assumption. So that this shows that our assumption was wrong one. So the true statement is that root 5 is rational. Sorry, root 5 is irrational. Let's consider the next question. Show that 3 plus root 5 is irrational. Here also we are assuming contrary that 3 plus root 5 is rational, and we are taking is P by Q form as A by 2. I can write root 5 as root 5 as A by B minus 3. Then I can rearrange this as A minus 3B divided by B. Then here is a contradiction because root 5 is irrational value that we have already proved in question number 1. Then in RHS is rational because here A is an integer, B is an integer, 3 is an integer. So A minus 3B also an integer, and B is already an integer. So this is a P by Q form. This is possible only if root 5 is rational, but root 5 is irrational. So that we cannot equate root 5 with an expression like this, A minus 3B by B. So this is a contradiction for the assumption or contradiction to the fact that we have already proved in question number 1. So that our assumption is wrong. That means this is a proof for 3 plus root 5 is irrational value. Let's consider the next question. Prove that the following are irrational. Here also, first of all, first step is we are assuming they are rational. Then we are following. Then we are following us 1 by root 2 can be written as A divided by B since it is rational value. Then I can equate, I can write root 2 is equal to B divided by A. This is not possible because root 2 is a rational value. We have already proved that is a fact. And B by A is this expression is possible only for rational values. So that our assumption in first case is wrong. Same way in 7 by root 5, second question. Let's consider the second question, 7 by root 5. There also we are equating that with A by B. And we can write root 5 as A divided by 7B. This is also not possible because root 5 is the rational value, and A divided by 7B, this expression, this LHS represents a rational value. This is a contradiction to the fact that root 5 is irrational value. So that our assumption is wrong. The right assumption is that 7 root 5 is irrational. This is a proof for showing root 5, 7 root 5 is also irrational value. Next, 6 plus root 2 also we can do in similar manner. 6 plus root 2 also can be 6. 6 plus root 2 also can be expressed as A divided by B. Then root 2 can be expressed as A divided by B minus 6. We will get then A minus 6B divided by B. Then this is a rational value, but this is the rational value, that is a fact. So we cannot equate them. There is a contradiction. That happened because of our wrong assumption. In these three cases, we can prove the given expressions are irrational in the same manner. Contrary, we are assuming rational and we are arriving at a contradiction. And we can state that this contradiction happens due to our incorrect assumption. Hence, we can prove these results as they are irrational values. Now, let's consider the fourth exercise of first chapter. First question is given us without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansion. So this is a question, and some of the numbers given us 13 divided by 3125, 3125. Let's find the behavior of its decimal expansion. For finding this, we have to find out the prime factorization of denominator 3125. We have to find the prime factorization here, and we can find it as so that you will get 13 divided by 5 raised to 5. Same can be written as 13 divided by 5 raised to 5 into 2 raised to 0. So this denominator is of the form 5 raised to m into 2 raised to n. If the denominator of a PYQ form, in a PYQ form of a rational number, if q is the form or the denominator is of the form 5 raised to m into 2 raised to n, then we can say that its decimal expansion will have terminating place values. So here we can say that the decimal expansion of this number will be terminating. And as part of question number 2, it's asked or it says that write down the decimal expansion of those rational values in question number 1, which has terminating decimal expansion. Here it has terminating decimal expansion, so that we have to find the decimal expansion of it. Then what will be the decimal expansion of it? I can write this as 13 into 2 raised to 5. I am multiplying 2 raised to 5 numerator and denominator, so that I will get 10 raised to 5 in denominator. So that I can write 13 into 2 raised to 5 divided by 10 raised to 5. And I will get the answer as 416 divided by 10 raised to 5. So I am counting 5 decimal places and I will get the answer as 0.00416 is the answer for this decimal form of this rational number. Let's consider the next question. The following real numbers have a decimal expansion as given below. In each case, decide whether they are rational or irrational. If they are rational and of the form p by q, what can you say about the prime factors of q? Okay, let's consider the first question, that is I have already written here 43.123456789. This is the first question. Let's consider this question. This is decimal expansion is given here, and after the decimal point there are 9 place values. So this number can be written in p by q form as 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, all divided by 10 raised to, how many decimal places are there? We know 9 decimal places. So we can write as 10 raised to 9. Then in next step, we can write the same numerator. That means the numerator is 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, all divided by 2 into 5, all raised to 9. That means I can write this 10 as 2 times 5, and power is, I have already put there as raised to 9. Then I can write the same thing as 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, all divided by 2 raised to 9 into 5 raised to 9. So that I can count here as the denominator in 2 raised to n into 5 raised to m form. So that we can say that its decimal expansion is terminating one. As its decimal expansion is terminating one, its denominator is of the form 2 raised to n into 5 raised to n. And the prime factorization of q, that means the denominator is 2 raised to 9 into 5 raised to 9. Second, consider the question. Second question given us 0.12012001200 like this a number is given. We can say that there is no repeating block of digits. So there is and this last etc shows that this is non-terminating. And we can see from this repeat from this given block of digits there is there we cannot find a block of digits repeating. So there is this we can analyze as non-terminating and non-recurring. So that this is an irrational value. This is not a rational value. Next question is given as 43 point repeating block of digits, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Here this much block of digits from 1 to 9. This block of digits are repeating. So obviously this is a rational number. This is recurring decimal places are there. This is a rational number having recurring decimal places. That means we can write this as 43.123456789. Again 1, 2, 3, 4, 5, 6, like that. This same block of digits are repeating again and again. Let's take this value as x. In order to find the p by q form of this value, we take this value as x. X is equal to 43.12345678912345678 like that. This number, this value we are taking as x. And then we are trying to find the value of 10 raised to 9 times x. 10 raised to 9 times x. So that we will get the value as 431234567889. This block of digits are again repeating. Then what I am going to do is subtracting. Next step, I am subtracting x from both sides. When subtracting x from both sides, I will get, for convenience, I shall write this 10 raised to 9 as 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 after 9 zeros. That I have written as 10 raised to 9. From there, I am subtracting this x. That means that much x minus x, so that I will get the RHS as 9, 9, 3, 4, 5, 6, 7, 8, 9. 9 times 9, this much value into x. So while subtracting, this is LHS. And in RHS, while I am subtracting this, I will get this, I will get a value without this decimal places. So that I will get the value that is being subtracted 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.12345678 minus 43.123456789. So here both of these numbers have same places, same place value digits are repeating. So this repeating decimal places were cancelled each other. And by subtraction, I will get the final answer as 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6. So this is a value of 9 times 9. Not actually 9 times 9. I'm writing 9 times 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This much times x. The value of this quantity is this one. So that now I will get x as x is equal to 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6, all divided by 9, 9. So from here we can conclude that x is rational since they are p by q form, and this value will not be in will not be in 2 raised to m into 5 raised to n form, because 3 is a factor. 3 is also will be a factor there, factor of it.